Let's do some math. Today we're going to be talking about triangle similarity and proving triangles are similar. There are three different ways to prove triangles are similar. But before we begin that, let's at least remember that there are two things you need to know if you have similar shapes. Number one is that the angles are congruent, and number two is that the sides are proportional. So anything that's similar means the sides are proportional and the angles are congruent. All right, so if we're going to prove triangles are congruent, there's three main ways that people usually do it, and that's knowing that all of the angles are the same. And this is called angle-angle similarity. And you might stop here and say, Mr. Fife, why didn't you say angle, angle, angle? Well, really, if you know two of the angles are the same, the third one has to be the same, because the third one will be the same in both triangles. 180 minus the other two that you already know are the same. So this is what this might look like. And I'm going to go ahead and angle, angle here. I'm going to zoom in. So here's one type of problem that you might get. It says determine if these examples are similar by angle, angle. All right, and if so, write a similarity statement. The way I like to do this is just find all three of these angles. I already know these two of them, but let's find all three of them. So I'm going to do 180 minus 74 minus 75. Okay, so I do 180 minus 74 minus 75 more, and I end up with 31. And over here on triangle DEF, I'm going to do the same thing. I'm going to do 180 minus 75 minus 31 more. And I do that, and I type it into my calculator, and I get 74. And now notice, there are two angles, angle, angle, 1 and 2. I'll highlight them in green. There's one angle and two angles that are the same in both triangles. Now, technically, like I said, all three of them are the same, but we really only need to know two of them. And so, these triangles are, let's see, let me do my little drawing pen again. These triangles are similar to each other, and so we can say triangle ABC is similar to triangle, and because this started with A, I'm going to pick D, because that's the 75 on triangle DEF. B is the 74, so E is the 74. C is the 31, so is F. Triangle ABC is similar to triangle DEF. Let's take a look at one more example. This one down here. Well, does this have two angles that are the same? You might say, Mr. Fife, none of the angles are marked. I don't know any of the numbers. True, but you do know that this angle and this angle are the same. That's what those little tick marks mean. And you might remember back to first semester, vertical angles are also the same. If you had me for first semester, you might remember vertical angles are actually my favorite. I love looking for this plus sign because I know that the angles on both sides of them are the same. And so, notice we have one angle, two angles right here. 1, 2. And that means, yes, we have an angle-angle similarity situation. And we can say triangle XWV is similar to triangle X. X is the same in both of them because it's the middle. W is the angle that's not marked, so I'm going to pick Z. V is the angle with one mark on it, so I'm going to pick Y because that's the angle with one mark in the other triangle. That's kind of how triangle similarity works. Now let's look at one or two more down here. Three more down here. Let's look at this triangle up here on top. Notice, let me pick a different color. We know that these angles right here are the same because they're vertical. That's all we know. We actually don't know anything about these four angles. So we can't say they're the same as each other. We know something about this side, but we're not worried about the side. And so we actually don't have enough information to make a good guess about this one. We only know one angle, and so if we only know one, then we don't know. It's like we don't know any. All right, let me pick blue here. So we have not enough information here. They might be similar, but we can't prove it yet. Let's check out this triangle, LMN and PON. This one, you might say, well, there's another. Do we know anything here? Well, check out N. N is in this tiny triangle, and N is in the really larger triangle. So n is the same as itself. Okay, so we have one angle. And then check out these little marks right here. These are called parallel marks. That means these angles right here are corresponding. So I'm going to put a tick mark there. And it also means these angles here are corresponding, which means they're the same. So we know all of the angles are the same in this one. So these two are similar by angle, angle. And let's check out one last one. You might say again, Mr. Fife, I don't see much, but you have these parallel marks. And we have this plus sign in the middle. So you might want to pause for a second and think, what do you know now that you think about the plus sign and the parallel mark? The parallel mark means that these two angles here are the same. They're alternate interior. And the parallel marks mean that these two are the same. They're alternate interior. This plus sign in the middle means that you have vertical angles. So again, we know all three angles are the same, so we have angle, angle, angle similarity. Finally, you're going to see a lot of this on your check today. Let me zoom out. It's going to say which triangle is similar to ABC. Okay, so to give you two options there. I'm working on the right side of the page here. Let me put a line down the middle. Anything on the right side of the page is what I'm working on. So, on the top one, I've got 57 degrees and 44 degrees. And what I would probably try to do first is find angle C. So I'm going to say 180 minus, and this time I'm going to add 57 and 44 together before I start. And so that gives me 1, carry 1 there, 101. 180 minus 101 leaves me with 79. Okay, so those are my three angle marks in that triangle. Are any of these triangles down below the same? Well, yeah, there's a 79 and a 44. So this one is similar to the top one by angle, angle. And I check out the bottom one. Hey, those two are similar by angle, angle. Both of these, so all three triangles, all three are similar. Similar. Ooh, spelled that wrong to begin with. Okay, all three of those are similar because they have two that are the same. On your practice assignment, you might see some that end up looking like this. So you'll have maybe a 90-degree mark up here, and say this one's 34. Are 90 and 34 like any of these other angles? Well, no, none of these are 90 or 34. And so if none of them are 90 or 34, it turns out that right away we don't even need to find this third one because we will never have two angles that are the same. So that one would not be similar. And we would say that, not similar. All right. That's one way to prove angles or triangles are similar, is angle, angle similarity. Let's check out one more way. This way is called side, side, side similarity. And in this case, we want to know that all the sides are proportional. The corresponding sides are proportional. And so notice, I'll just show you a couple quick examples here. This 3 doubles to be the 6. This 4 doubles to be the 8. Okay, we multiply it by 2. This 5 here, to get to 10, what do? We multiply by 2. This has a scale factor of 2 going from the small triangle PQR to the large triangle STU. So these are similar because the sides are proportional. If you're able to find a scale factor like that, the sides are proportional. Let me show you a different way on number 4 down here. So number 4, the numbers are a little bit bigger, and so I can't quite just double things in my head. What I would need to do on number 4 is set up proportions or ratios. So I'm going to put 30. 30 is the smallest number. I'm going to put 30 over, and then I'll pick the smallest number on this triangle on the right. 30 over 24. And I'll say, hey, does that equal 32, the mediumest number, 25, the mediumest number? And does that equal, I'm going to pick the largest number, 35, over the largest number, 28. And what's going to happen is I type all of those into my calculator. Let me grab my calculator real quick. And as I type all of those into my calculator, I find out that 30 divided by 24 is 1.25. And 32 divided by 25 is 1.28. Uh-oh, those two aren't the same. And 35 divided by 28, well, that's 1.25 again. But notice that the middle one wasn't the same. This 1.28 is different. That means this is not proportional. These sides are not proportional, so these are not similar. And that's all there is to it with side, side, side. You either decide that they're all the same, they all end up with the same ratio when you do smallest over smallest, medium over medium, and largest over largest. They have the same scale factor, or they don't. Let's check out another example and see if we can figure this one out. Here we got 26, 26, and 30. So let me put smallest over smallest, 13, 13, and 15. So 26 over 13. Mediumest, well, I guess it'd still be 26 over 13. And largest, 30 over 15. I go over to my calculator. 26 divided by 13 is 2. 26 divided by 13 is 2. 30 divided by 15 is 2. Their scale factors are the same, so we have side, side, side similarity. These triangles are similar. Cool. All right, and here's kind of what you'll see on your homework a lot, or on your practice assignment. You'll see 3 like this, and it'll say which triangles are similar. Okay, so this top triangle, we have 5, 8, and 11. Those are our side lengths, 5, 8, and 11. And these middle triangles are a little bit different, the middle and the bottom triangles. They're not 5, 8, and 11. Let's figure out if they're proportional, though. So I have 5, and 25 is the smallest side down here. Even though the 5's on top and the 25's on bottom in the middle triangle, they're both the smallest sides of their respective triangle. So the 5 is smaller than the 8 or the 11. The 25 is smaller than the 40 or the 55. Now, to get from 5 to 25, what do you multiply by? This is how I like to do these problems. Well, the scale factor would be 5. So 25 divided by 5 gives me 5. And let's see if it's the same for all the other ones. So let's pick the mediumest side. That's the 40 and the 8. Well, 40 divided by 8 is also 5. Hey, we're on a roll here. Let's pick the biggest sides now. 55 divided by 11. That's also 5. So these all have the same scale factor. So triangle ABC is definitely similar to triangle DEF. Cool. Let's check out if the last one is similar. The smallest of these numbers is the 0.5. So the smallest up here was just 5. So we could do 5 divided by 0.5. And when I do 5 divided by 0.5, I get 10. Now let's check a couple of these other ones out. Now we'll do the medium numbers. 8 divided by 0.8. And what I get is 10 again. Okay, let's do one more. 1.1 is the biggest, and 11 is the biggest. So 11 divided by 1.1 gives me 10 again. Hey, this one is also similar because they all have the same scale factor. Cool. So I could say all 3 of these triangles are similar. Let's check out the last way to prove that triangles are similar, and that's by side angle side. So you have an angle that's in the middle of the 2 sides. Okay, so in this one, you have to have an angle that's the same, that's congruent, and boom, angle K is congruent to angle N. And then the sides, this 8 and the 6, and this 20 and the 15, they have to be proportional. So I still need to say 6 over 8, so that was smallest and smallest. Let's pick, is that equal to the biggest? Since 6 was in the right triangle, notice this 6 here, it's in the triangle on the right. I'm going to put the 15, the bigger number from the triangle on the right, I'm going to put it on top. And then I'll put 20 on bottom. When I divide these, I get 0.75 for both of them, so the scale factor is the same. That means these are side angle side similar. That's great. And let's check out the bottom one. The bottom one, you might say, well, Mr. Fife, that looks like one triangle to me. I'm going to zoom in on it a little bit so we can see it better. And it turns out that's 2 triangles. There's a tiny one right here. tinier one, I guess. And then there's a large one that goes all the way up here. And so when you look at this one, this angle is the same in both triangles. Angle A is in both triangles, the small one and the large one. So it's the same as itself. What we would need to decide is, are the sides proportional? So we can say 15, smaller triangle, over 25. Is that equal to 12 over 21? And when we do this math here, 15 divided by 25, we end up with 0.6. And when we do 12 divided by 21, we end up with 0.57. So are these triangles similar? What color do I want here? No! These triangles are not similar. They do not have side angle side similarity. In fact, the sides are not proportional. And so we say no, they're not similar. Let's take a look at one or two. I think there are two other examples for side angle side. If you take a look at these two right here, this example, there is an angle, and it is right in the middle of two sides. It has to be in the middle of those two sides. It has to be connecting to both sides. And here's an angle that is congruent. They're both 90-degree angles, and it's in the middle of two sides. So I'm thinking I'm going to check side angle side similarity. Let me pick the small number in the right triangle, small number in the left triangle. Hey, 5 over 10, well, that's just 1/2, 0.5. Is that equal to big number in the left triangle, big number in the right triangle? 14 divided by 28, well, that's also 0.5. So, yay, these are proportional. It has the same scale factor with an angle in the middle. So the sides are proportional, the angles are congruent. So it's side angle side similar. Let's check out one more. Is this side angle side similar? Well, I've got an angle here that's the same. That's a good start. Need an angle that's congruent. And then we need sides that are proportional. Well, I know something about this side. Let me pick a different color for a second. I know something about this side right here. And I know something about this side right here. So then I guess I would need to know something about this side because the angle needs to be in the middle. But do I know anything about that side? No. And I would need to know something about this side because again, the angle then is in the middle of both the sides. But I don't know anything about that side, so I don't yet have enough information. So you can write, I don't have enough info to answer that question yet. All right, there is one more problem I'd like to look at, and it doesn't quite have to do with side angle side. It's on this page, but it's a little different. This is a word problem, but it's a really good one. A 1.6 meter tall woman stands next to the Eiffel Tower. So here's a person, and they stand next to the Eiffel Tower. The Eiffel Tower looks big and tall like this. Something like that. Okay, so at this time of day, her shadow is 0.5 meters long. So let's draw, let's see, the sun over here. And the shadow is on the ground here. Okay, the sun kind of comes at this angle, and it's the same angle for both of them because that's how the sun works. And it creates a shadow that's 0.5 meters long. At the same time of day, the tower's shadow is 106.25 meters long. Okay, and it says she is 1.6 meters tall. You might say, Mr. Five, what does this have to do with similarity? Why in the world are we learning this? Well, check this out. People, when they stand at right angles. Same thing for buildings. Okay, this thing here is at a right angle. And since the sun is hitting them both at the same angle, that means this angle up here is the same for both of them, and they create a triangle. Okay, with the shadow and how they're standing. And that means we have, because this angle here, one angle is the same, and two angles, the right angle is the same, we have angle-angle similarity. These two triangles that the people and the tower create are proportional. Well, they're similar, which means the sides are proportional. So we can say 0.5, the shadow, over 106.25, the shadow of the Eiffel Tower, is like the person's height over the building's height. Well, we don't know the building's height. We can call it x. And so, if we're doing this, we can cross multiply 5x equals 106.25 times 1.6 is 170. And when we divide on either side here, we get 170 divided by 0.5 equals 340 feet. Was it feet? Nope, meters. Sorry. Meters tall is the Eiffel Tower. All right. Remember, angle, angle, side, 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 and side, angle, side. If you're checking angles, they have to be the same in both triangles. If you're checking sides, you check proportions. So you set up little ratios, smallest over smallest, biggest over biggest, medium over medium, and you check to see that the sides are proportional. If that works, your triangles are similar. If it doesn't work, your triangles are not similar. And if you don't quite have enough information to even start, you just don't know yet. All right, good luck on your practice assignment. I hope to help you some more. Reach out if you need help.